Financial Modeling, Topic 16, the Black-Scholes-Merton Option Pricing Model, Implied Vols, and Volatility Estimation. References are from Simon Beninga's Financial Modeling, 4th edition, and you can look at the chapters on options, the Black-Scholes model, the Black-Scholes Greeks, Monte Carlo methods, and simulation. Section 1. We're going to calculate the implied volatility using solver and a VBA function. So let's first start with solver. Say the March 6:15 strike on Google is selling for 10.05 and 11.05 respectively. The implied volatility is the standard deviation Black-Scholes-Merton model parameter that equates the Black-Scholes model price to the market price. What we're going to do is simply run solver and try to set the Black-Scholes price equal to the market price. So I'll go to the spreadsheet and you'll see that I have today's date, the strike, the stock price, so that would be the spot price of the underlying stock, the dividend yield, the risk-free rate for the maturity of the option, the maturity of the option. In this one, I calculated that it had 13 days left to maturity. So I took 13 days divided by 252 to get the maturity in years that Black-Scholes needs as a parameter. Notice there's a note here. In the last section, I took calendar days simply by taking the difference between these 2 days and divide by 365. The alternative is to take business days divided by 252. And just make sure you're consistent. If you take number of business days, make sure you divide by the number of business days in the year. And for equities, that's 252. And for calendar days, you would simply divide the difference or the number of calendar days to expiration divided by 365. And I already have functions in this worksheet, and I have BS call and BS put. So what I'll do is I'll insert the BS call models, and what I'm going to use is a volatility input of 30%. That was the roughly the recent volatility on this underlying stock. So I'm just going to put in BS call. I'll launch that. I'll go ahead and put in the current spot price, 614. I'll anchor that. The strike price, 615, anchor it. The volatility, I'll put 30%. The interest rate, 10 basis points. The maturity in years, 0.05. Anchoring all this, and the dividend yield of 0. Anchor that. And what you see is the BS call price is 1636, so that is the model price according to the Black-Scholes-Merton model, or sometimes called Black-Scholes model, using a volatility of 30%. If I copy that formula down, I'll change this to BS put. I know that BS put has the same parameters in the same order. So according to Black-Scholes, the call should be selling at 1636 and the put at 1706 using a vol of 30%. However, I know that these options are selling for 10.05 and 11.05 in financial markets. So what I could do is I can either say, well, these options appear to be very undervalued. I think they're worth 16 or 17 and they're actually selling for 10 or 11. Or you can do this little exercise. You can say, well, what volatility, if I input into Black-Scholes, will make this number the market price 10.05 and this number 11.05. So I can simply go data, what if, goal seek. And what I'm going to do is I'm going to set that Black-Scholes call price to 10.05 by changing the volatility estimate. And hit OK. And it looks like that is $10.05. If the volatility is 1867, I'll hit OK. So the implied vol is 18.67%. It is the Black-Scholes volatility input, annualized standard deviation, that sets the Black-Scholes model price equal to the market price. And I'll do the same thing for the put. What if, goal seek, I'll set the put price to the market price 11.05 by changing volatility. And it looks like it's 1921. So what we call this are the Black-Scholes implied volatilities for Google stock over the next 13 business days. It's been shown that these volatilities are better estimates than just, say, recent history, which was based on that, what that 30% was based on. So that's how we calculate implied volatility. These implied volatilities are then used in many different situations. So what I'm going to do now is show you a function that can do what we just did. It's basically going to replicate Excel's goal seek. And the nice thing about this function is you don't have to run solver if you just simply have enter the market price as a parameter and use the Black-Scholes model, and this will actually calculate the implied vol for a put, and the next slide will be for a call. So this function is called put vol. It has the same parameters as Black-Scholes in the same order: spot, strike, interest rate, maturity, dividend yield, and then an extra parameter, market price of the put. And here's how this function works. We're going to say that high vol and low vol is going to be our range of possible volatilities, implied volatilities. And I think they're between 0% and 100%. So I'm going to set up a range that the vol is going to be between 0 and 100%. So I said high vol equal to 1 and low vol equal to 0. And then I'm going to do a do-while loop. We haven't done a do-while loop. Now, when we do for loops, we're going to say do a for loop and say for I equal 1 to 1,000. It'll do something in the middle here, say exactly 1,000 times. However, when you do a do-while loop, it's going to do these statements between the do-while and the loop as long as this condition is met. So do while, the difference between high vol and low vol is greater than 1 basis points. Right now, a high vol is 1, low vol is 0. So that is 1. 1 is greater than 0.0001. Therefore, it is going to execute these 4 lines of code. So it first calculates that this is true. It is true. High vol minus low vol is greater than 0.01. So it's going to do these statements in order. And here it is. It's actually an if-then-else statement. If BS put, where we have spot, strike, vol, R, and T. Now here's what's going on here. BS put is the name of another function that we went over in the last topic, and that is the Black-Scholes model. So this is actually calling upon the Black-Scholes user-defined function within this function. And if I go to my spreadsheet, note, and then I go Alt F11, and then go to my VBA, you'll notice that BS call and BS put are input right here. And then you'll notice that I have put vol and call vol. So this function will only work, put vol will only work if BS call is, or put vol will only work if BS put is also in the same spreadsheet. And call vol will only work if BS call is on there. So let's go back to our presentation. So this line of code right here, well, let me go back to that, is going to first say if the Black-Scholes price using the spot strike that I've input and the vol. Notice in this function here, vol is not a parameter in this function, even though in BS put it is, because I'm going to calculate V in this function. So if BS put using that spot, that strike, and the average of high vol and low vol, which currently are the average of 0 and 1 is 50%. So what it's going to do, it's going to value this put using a vol of 50%, and then it gets the R, T, and D from R, T, and D. And let me clean this up a little bit. So it's going to value the put using 50%. And if that's greater than the value of the market price of the option, then it's going to execute this line of code. Else, it's going to execute that line of code. So let's go back to spreadsheet. So it's going to value BS put using 50%. Let me get rid of that. So it's basically going to type in, it's going to have 50% in the function. So it's going to value the price, the put at $28.18. All right, internally, this program is going to value the put at $28.18. $28 and some change. We know that the market price is 10.05. We're going to input that as a parameter. So what that says is it's going to say the model price is greater than the market price. So it's going to execute this line of code. It's going to take the high vol and set it to the average of high and low. So in other words, high vol is going to become 50%. And so this line doesn't get executed. And it goes back to the loop. Now, here's what's happened. All right, these lines are not being executed anymore. They're outside the loop. However, it is reset high vol equal to 50%. So now it's going to say do while the difference between high vol and low vol is greater than 0.0001. So high vol is now 50%. Low vol is now still 0. It's now going to value the option using the average of high and low, which is now what the average of 50 and 0. It's going to use 25%. When it does that, it's going to get another price. And we can go back to the spreadsheet. It's going to revalue this option using 25%. And that's going to give me a put price of $14, which is still higher than the 11.05. Let me actually, I wrote that down wrong. It's 11.05 there. Okay, 11.05 for the put. So it is still too high. So when it goes and writes this, it's going to say, okay, the Black-Scholes price is still greater than the market price, so let's lower high vol again. So now it's going to set high vol equal to the average of high and low again. Now high now is 50, low is 0. So it's going to use an average of 50 and 0. So it's going to use 25%. So now high vol is 25%. It's now going to get to the end of the loop, come back up. It's now going to value the option using the average of 25, which is high vol, and 0. It's going to value the option using 12.5% as the volatility. Now you'll notice if it tries to use 12.5%, it's going to get a put price of $7, which now is too low. So go back to my program. It's now going to go back to the loop. It's going to value at 12%. It's going to be too low. So it's not going to execute this line of code. It's going to execute the else line of code in the if-then statement. It's going to raise low vol from 0 to now the average of high and low, 12.5. So now high vol is 25, low vol is 12.5. The average of high and low, that would be, what was that, 3750 divided by 2. It's then going to use that. So this is the method that this program works. Anytime the model price is greater than the market, it's going to lower high vol. However, once it gets too below it, it's then going to raise low vol. And the way it does is we know it's between 1 and 0%. And what it starts doing is it starts lowering high vol until it gets too low, and then it starts raising low vol. And it does this process where it just gets really close, and at some point the difference between high vol and low vol is between 1 basis point, and the loop is done. And then I just put one last step. Even though the difference at the end of the loop, the difference between high vol and low vol is less than 1 basis point, I just take the average of the two and I end the function there. Here's call vol, does the same thing, except it uses BS call and not BS put. So that is the functions. We'll go ahead and use those functions. I have them in my spreadsheet already. So I'm going to type in put vol. Click on my function. I'll go ahead and put in my spot, 614, my strike, 615, interest rate, maturity, interest rate, maturity, dividend yield. Come down here, market price. So it looks like I got it all in there. Whoops, the market price, that's a put, so that price should be 11.05. And there's my 1921 for the put. And if I replicate for the call, I'll get exactly 18.67. All right, so that's the functions for calculating implied vol for a put and a call. Now the uses of implied volatility. First of all, it's a very handy quoting mechanism. Option sellers will often not quote the dollar price of an option. They'll simply say this option is selling for 18% volatility. What that allows the counterparty to do is then put that 18% into their Black-Scholes model, which they're looking at on their Bloomberg screen or spreadsheet, and calculate the price. That implied volatility is also used as a standard deviation estimate for portfolio optimization, like we did in earlier topics. That standard deviation can also be used as a value at risk parameter when you need a standard deviation. Also, if you want to value one option, you can simply steal the implied volatility of a similar option, say of the same underlying stock with similar maturity. And lastly, it's often used as a test of the Black-Scholes model, or the Black-Scholes-Merton model. According to Black-Scholes-Merton, the underlying asset return volatility is constant, which is called homoscedasticity, and therefore the implied volatility for a particular stock should be the same for all option maturities and strike prices. So if we calculate the implied volatility of Google for different maturities, for calls and puts and different strikes, they should all be the same according to Black-Scholes. So in this topic, we calculated the implied volatility using solver and a VBA function and talked about how or what implied volatilities are used for.